everyone. It is a beautiful Friday. I am happy that you are here with us. My name is Liz Merkel, and I work at the Data Institute. And all of these talks are sponsored by the Data Institute here at the University of San Francisco, which is the umbrella organization for all data science and data engineering programming and research that happens here. So on behalf to our students, welcome back. To our guests, welcome, and we're really happy to have you. Today's session will be with David Aronchick. He is the CEO of Expanso, a Seattle-based software company specializing in distributed computing solutions. David has been at the forefront of cloud and AI infrastructure. He helped launch Google Kubernetes engine, co-founded Kubeflow, and led open source ML strategy at Azure. Today, he's here to talk about his latest work, the Bacalhau Project, an open source platform that's making it easier to run machine learning models across regions, clouds, and edge devices. As businesses increasingly push compute closer to where data and users are, Bacalhau offers a powerful solution to simplify deployment and boost systems resilience, all without overburdening your developers, or its developers, I would say. So please join me in welcoming David.
And 30 minutes, or do you care? I have time.
Yeah, we have an hour, so you can build in your Q&A.
I love it. I've certainly actually sat exactly where you are. I always want to ask questions. Please, I love questions, so don't hesitate. And especially if I say something, I'm so deep in this world, it's so easy to forget. I don't know, in my head, I still mix up training and inference, for example. They're just the worst terms, and yet, that's what we use all the time. Anyhow, I am here to talk about Bacalhau and Expanso and what we're doing. But really, I want to talk about a general architecture that I think is going to be a real movement for the way that people change their infrastructure into the future. And that's because of the reality of the way that people are actually using all this data and data science and machine learning. So you may ask who this guy is. I've been very, very lucky, right? I happen to be in the right place at the right time. And it's funny because I remember when I joined Google to lead Kubernetes, I was like, oh, all the good stuff happened in cloud in like the early 2000s, right? When AWS was getting going, this is just kind of like pickup. And now everyone looks back and they're like, oh my God, when you were there at Kubernetes, it was that incredible. I promise, time is not lost. You're at a new advent, and in 10 years, there'll be a new advent from there. But I have been very, very lucky. On the left-hand side of the screen, you can see I worked at all the major clouds in various capacities. And then on the right-hand side, I was able to participate in some very, very large open source projects. Again, I was lucky to be in the right place at the right time. Just because I led or co-founded them, it couldn't have existed without the communities that built up around it. So I've kind of seen both sides of the world, the very commercial side and the very open source side. And when talking about data, like something that you all face on a daily basis, this is where I got my start. Graduated college, I want to be a doctor. Very foolish career choice by me. But to not go into medicine. Instead, I moved bits around. It's very stupid. But I started working at the NIH, and it was really funny. In the old days, because I have gray hair, I know what the old days look like, right? In the old days, this is what it looked like to share data, right? You had an FTP link. You had a very specific link at the government website. I actually think when I was putting the slides together, which was a couple months ago, I think I actually got this from a real website. I'm actually not joking. They still offer FTP, which is crazy. But surely this isn't how things work now, except they are, right? What you see there is an actual live link to the NOAA, I don't know until it gets shut down by Doge, the NOAA repository. Literally, that's it. It's the exact same thing. And it's really not a very reliable way to work. And you're like, well, it kind of works, right? Except, does it, right? It's It's secure in that you're transmitting over SSL, but it's not secure in that there's no auth, you don't know who downloaded it, those kind of things. It's self-managed, meaning there is no like broad hashing or identification of exactly what this file is. This one happens to be hosted through the largesse of AWS, which we're very thankful for, but God forbid they have a budget change or something like that. That goes away, yet this is government data. So if it did go away, how would you get access to that? The metadata for this file is in the URL. Like, what a terrible place for it. Because what happens? You download it, and then you have no idea where it came from. You have no idea what the metadata is, anything like that. It's also non-deterministic. And for those, again, forgive me if this is all redundant for everyone, but deterministic means, you do a thing. You tell a computer to do a thing, and it does the thing every single time. You don't know that with this file. Someone could come along and swap it out with no maliciousness. They're just like, hey, you know what? Oh, we forgot Bolivia as part of this satellite data set. We need to update the satellite data set and so on. That means someone who ran this last week and is now running it today is getting different answers, right? If they downloaded it and fresh each time, right? Super easy to make that mistake. This happens all the time. And we haven't even gotten to deploying, right? So now we're just talking about the beginning of your pipeline, the training and so on and so forth. We haven't even gotten to deploying. This is very common, what you see here. This is a real world example where you might have someone who has some things on a hyperscale cloud. If you're doing your job properly, you have them in multiple regions. You don't have them in a single region because even in hyperscale clouds, things go down. Maybe you have some stuff on other clouds. Maybe you have some stuff on-prem. Maybe you have some stuff on edge, far edge, whatever you want to call it. Your developer does a great job, and she's like, this is awesome. My app's ready to go. Out. And just throws it over the wall to the SRE, and the SRE is very unhappy, right? SRE is a site reliability engineer. It's a common term for developers who also do deployments and management and maintenance in larger organizations. And the reason is because rolling out applications is very hard. And these things get so lost. I posted this on Blue Sky the other day. I said, hey, what problems have you had? This wasn't even the complete list, right? Not even close. And it's just so many ways to go wrong. And yet, people think of this basically as an afterthought. Or it just doesn't work at all for no discernible reason. Now, you may say, well, wait a second, aren't I talking about applications? I want to say a spicy thing here, right? Which is, everyone's like, oh, models, AI, ML, blah, 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 blah. No. A model is just an application. It's a binary, it's got some stuff in it, it's got some dependencies, it's got some endpoints, it's got a contract that it uses to interact with other applications. That's it. It's not special. Don't treat it as something special. Don't reinvent model deployment in some new way. The best thing you can do is leverage the years and years of work that has gone in to rolling out applications, but do it with models, right? And I'll get to how that looks in just a second. So then you say, fine, the problem here was that it was distributed and spread all over the place. Instead, we're just going to build one giant machine, right? Oh, by simplifying, by removing microservices, everything gets better. And our SRE is still very unhappy. Why? Because everything that you had before is still the same. Even though it's just one machine. You're like, but isn't it supposed to be easier? And you're like, well, it really isn't. Like, how do you know what was deployed? Where? What configuration? What management? What tools? What dependencies are there? Is it still running? Et cetera, et cetera. And, by the way, we haven't even touched on data, right? Remember that stuff I was talking about at the beginning? Where I was like, if I just put all this data into a single central data lake, I'm going to solve all my problems. Turns out that before you move the data, ingest it into that data lake, you got a whole bunch of problems. And then after you ingest it, you got a whole bunch of problems, right? And again, this is the kind of thing where people are just like, oh, I'll take care of that later. I have my CSV, the model works on my machine, I'm calling it a day. And I'm telling you, if you don't think about this a little bit, I'm not saying premature optimization, but if you don't think about this at least a little bit at the start, how you're going to package it, how you're going to roll it out, how you're going to update it, how you're going to configure it, you're going to be in for bad times when you get to any reasonable size. You may say, well, no, I'm very smart. I'm going to use bash. because I swear to God, bash is everywhere. You like trying to get rid of it is like trying to kill a cockroach. But don't get rid of it. It serves a wonderful purpose. It is ubiquitous. It is valuable. It is known. There's tooling around it. It's great. But don't use it for everything because of all those things on the right-hand side, and we haven't even gotten into it, right? Once you use it, how do you know it deployed? How do you know it ran properly? How do you know if there's a bad network connection and it fails midway through? Once maybe it deployed properly, but you didn't get the notification properly, so on and so forth. What if you need to update it automatically? You know, all that good stuff. Okay, so you may be asking why is this so complicated? And I will argue that the problem here goes all the way back to what we were saying at the beginning. You know, you're trying to run your models where your users are. Simply asking all your users to bring their requests into a central database, or excuse me, a central single zone sitting in Iowa somewhere is a recipe for disaster. And one of the biggest gaps here is that the tooling that we ask people to take on, ask data scientists to take on, lacks these three characteristics, right? Not familiar, not simplified, and not collaborative. And let me tell you what those look like in just a second. So familiar is, you know, again, when you're building your model and when you're thinking about how to run it, people say, like, again, model works great, can't wait. This is awesome, it runs on my machine, you know, 3% loss, incredible. But that's not building a model. This is building a model, right? It's everything around it. The model is kind of the easy bit, right? You have the framework, you have a tool, you know how to do it. How did you get your data in? How did you track it? What's the lineage? How did you train? What were your hyperparameters? How are you recording it? What does the drift look like from last week, last month, last year? Once you roll it out, how do you know it's still running? What version is out there? All that kind of stuff. Having this be a declarative but simple format that helps you roll this thing out is critical. Huge, huge, huge gap in the industry today. Huge gap. Now, there are ways to hack at it even today, right? If you simply take all your stuff and put it into a declarative format like a container or a signed binary or something like that, you're actually off to a good start. And you're probably like going to tackle a few of these things, but even so, you're not there yet. And really thinking about how you do this in a platform way is super powerful. By the way, when I was putting some of these slides together, this is an old presentation that I did. This chart comes from Microsoft in about 2019. And we did a survey internally about the different tools they use. This is Microsoft, one of the most sophisticated organizations in the world for building ML pipelines, and they had 163 different tools that they answered on their what do you call it, right? So, you know, I'm not saying to ask them to change their tooling. I'm saying instead, the platform should enable them to use the tooling that makes sense to them. So that's a really, and we haven't even gotten to platforms like, you know, the way to compute providers, data providers, and so on. So we want to be familiar. We want to meet people where they are. Second, we want it to be simplified, right? So it's funny. I used to do this with just Jupyter notebooks and things like that. Now people are a little bit more advanced, but still, Jupyter Notebook is like the standard, right? And so I'm sure all of you who've gone through any data science course have popped open a Jupyter Notebook and opened up the housing crisis CSV and run the regression against that and see still love linear regression. It's amazing. This is the housing crisis when you do it in pandas. It's two commands, two lines of code, one of which is to print it out, right? So very, very straightforward. Spark, Databricks, Mason Company. This is the exact same code in Spark to do the exact same thing, and it's not even all there, right? I couldn't fit it all in the slide. Now, is that bad? No, it does its job. It's like a different purpose and those kind of things. But at the same time, like, this is what we're asking data scientists to do today. And so the extent to which we can keep it simple, let them use the tools they know and love without having to adopt a new SDK and things like that, that is going to be a winner. That's going to help people get there. And when you go out, if you don't already have jobs, and you go out as a data scientist and so on, and you explain, hey, you know what? I know you have this defined toolkit to roll things out. Let me show you how to work inside that toolkit. That's going to help you accelerate and help the organization that you joined accelerate if you haven't joined already. What many developers actually want, I love to joke about this. This is SED. I use SED all the time. SED's amazing. It's 48 years old. Actually, it's a little bit older than that now. This was a slide from last year. 49 years old. Yeah, it still works. It works great. Stop trying to reinvent it. Instead, how do you help people use SED on Databricks without having to port or adopt the SDK and things like that? So, one thing that everyone can agree on, data pipeline side. And then finally, collaborative. So again, another big thing here is that more often than not, you're doing work on your laptop, you're using your own private data sets, and so on. And they could be from public data sets, but the problem is that there's no collaboration. Like, how do you exactly share these kind of things between people? So in this case, let's say you have 3 different data scientists, each of whom are doing something slightly different with satellite data. So each of those satellite data slices, they're quite large. They can be, a gigabyte or larger, a single image, because of the resolution. Somebody maybe wants it tiled, so that's where you take it and you shrink it down. Somebody wants it scaled, so I want the entire thing, but at lower resolution because I need a larger vision. Some people do it grayscale. So this is very common when you want to input a lot of different data. You don't need the kind of color resolution at all. You just need shapes of mountains and things. Each one of those people has done a set of work, and now this final data scientist would love to pull from all of those bits of work. And if all of that, if the entire tool chain, if everything is sitting on someone's laptop or a very big developer machine or something, and not being checked in and not using pipelines, then it's very hard to collaborate. Ideally, you had a situation where each person was able to publish their work in a declarative format with a hash, and then this person was able to select from those various pipelines and merge them together. So again, this is where pipeline thinking, even with your Jupyter Notebook, and I want to stress, a Jupyter Notebook is a pipeline, if that's what you're using. A Python script is a pipeline. It just happens to be all in a single sheet. Every one of those cells triggers something else. It effectively is a DAG. Keep using that. So our goal here is to get the familiar, simplified, and collaborative. And it is to do this, right? So Bacalhau, the open source project, compute over data architecture, which I'll talk about a little bit more, is not trying to change anything on the right-hand side of this slide. Nothing. Not a single line of code. We are trying to make it more efficient by putting the information and metadata and training and so on in the left-hand side and have that be well-structured so that any of the tools you already know and love simply get better. The architecture I mentioned several times is called compute over data. The reason we came up with this, or this very strange name, we happen to have been in Portugal when we were working on it. And in Portugal, when you are talking about COD, C-O-D, it means Bacalhau. So that's how it gets the name. The company name is called Expanso. It's a slight derivation of how you say distributed in Portuguese. Again, we were there, we were drinking wine, I don't know, or we thought it was very cute, but we couldn't, the real word is has an accent and whatever in the middle, and we're like, this is not happening. So we're going to simplify it. But the whole goal is to process your jobs in place, to minimize leaking or moving data, but do it in all the ways that I talked about earlier. Reproducible, hashable, verifiable, declarative, and so on. And its key scenarios, and I'll get to some of the specific use cases in just a second, are all about transforming your data before you move it in that reliable, repeatable way. Executing over poor networking, because all networking is poor networking. It's not because people are unresponsive or irresponsible. It's because that's what TCP is designed for. And so unless your pipelines and your systems are resilient over networking that can drop in and out, then you're going to be in, And then also using data in isolation. Because then, if you don't have to move all your data, if you can do it thoughtfully, remotely, with hashes, with clarity, with security, then you can move subsets of data instead of having to move it all. It's a very powerful change in concept. And I think it's absolutely the way the industry is going to go, and we would love to participate in it. So we really help you use your applications everywhere. And because I'm a Kubernetes guy, I always want to stress, like, it's not a replacement for Kubernetes. It sounds a lot like Kubernetes, but it is really like an add-on to Kubernetes and those central other architectures that you're talking about. And by that I mean, look, you have all these things on the right-hand side. On the left-hand side, we are multi-region, multi-cloud. We operate on edge, IoT, unmanaged infrastructure. We run on low resource devices, so on and so forth. And so you, as a data scientist, as a site reliability engineer, all of the above, you now can operate across this global infrastructure that you may have, even as though it was all sitting inside a single data center. And I know you're like, well, I only have 3 machines. It can't be that big a deal. I promise you. If you have an Ethernet quick cable, you have a distributed system. You will have this problem. You will have things go out of sync. You will have, hey, exactly what copy of what thing was on this machine versus that machine. How do I know? How do I query it? How do I have an API? Et cetera, et cetera. And then because your overall data is smaller, cleaner, your pipeline's more efficient, and so on. So that's a lot of talk. I'm going to get to some use cases here. I want to take just 1 second just to make sure that anyone has any questions or thoughts. Anything I said that needs a vocab? I promise. No? Okay. So 3 big scenarios, then I'll get to a live demo here in just a second. The first is what's called a distributed data warehouse. So today you might have a situation where you're interacting with a bunch of IoT sensors, remote devices, factory floors, retail, you name it. This IoT data is often very poorly structured. These are very low-cost devices manufactured in wherever, Shenzhen. They have no idea how they're going to be used, and they simply output raw data. If you're lucky, it's like schematized to JSON. More often than not, it's just like a flat, line-by-line sensor. And you probe it, and you get an answer back. Here's the temperature, here's the time. That's it. And then it's up to you to structure it. How do you take that data and make sense of it? Well, you first need to wrap it with a bunch of metadata. Where was it? What's the GPS coordinates? What location? Upper right corner of this building, this room. What time it was? What local time it was? Because don't do it on GMT, because then you're going to be like, why is it 35 degrees C at midnight? So you got to be really thoughtful about what you're wrapping around that, and then you move it to some central data lake. That's more often than not. Now, the problem with that is you're often moving stuff that's too large, that's too big to be stored. A real-life example we're working with right now, a solar company has a bunch of fields in Southwest Australia. The inverters at each of those panels is generating a bunch of data. They want that data because they need to predict what the next hour of generation time looks like so that they know whether or not to spin up gas plants because something's behind a cloud or whatever it might be. The data being generated off the inverter is on a per second basis, okay? But their models for predicting this stuff are on 10-minute windows. And that's makes sense, right? Like, there was just, somebody walked in front of a solar panel, so the output dropped off. They want to average it, they want to streamline it. That definitionally means they're moving 600 times too much data, right? It would be much better for them to wait 10 minutes, average it up, and send 1 bit of data instead of 600. And again, this is not just one, right? There are literally thousands of inverters. Being thoughtful about what the data you're moving is, how you aggregated it. So now, great, you have the aggregation in place. How do you know what you were using to do around that? You have to wrap that metadata as well, any transformations and things that occurred. You want to do that as well. So, and then, of course, we didn't get data from this field. What happened? Like, was it the machines went down? Was it that there was network interconnectivity? So on and so forth. Unless you have something that is looking over the top of these things and know whether or not the connection is there, you're going to have a problem. And worse, a lot of times you'll get to the end of this and you want to take action faster, but it requires waiting for that data to make it all the way through your pipeline to the end of your ML model before you can take action. And that could be, if you're very lucky, minutes, and if you're like some of the companies we work with, literally months before that data gets all the way through the pipeline. If you're able to take some action earlier, you reduce alert fatigue, you can be much more thoughtful, and do automated remediation and things like that. So what we do is, we propose an architecture like this, and this is very common. You have, in each location, each geographic location, you have what we call near compute. So that's a machine that you would set up yourself. It would be just a standard 2U machine off the shelf, $1,000, whatever. And all your sensors go into that local machine. And that in that local machine, it stores it in an efficient way, iceberg, parquet, take your pick. Stores it locally, and then does some initial aggregation, analysis, and so on there, and then pushes only portions of the data that make sense to you. But it still keeps it there. Now again, I'm not saying leave it there forever, necessarily. There's every possibility that you're like, no, we have archival purposes, we want to move it, that's fine. But you can have it go through multiple pipelines once it lands at that place. And this also, by the way, saves money, saves efficiency and things like that. It also allows you to do distributed data warehousing. So now your developer comes along and she says, I would like to query, I've got the summary data. I want to query every machine in my system, right now. How do I do that in an ad hoc way? She can issue her query to the network, this compute over data network, in this case it's Bacalhau, but like other architectures certainly support that, and then that distributes the query to all those locations and gets an answer back. And she did that without moving all that raw data into a data lake, right? She's able to do that distributed query and issue that. Second big category is around optimizing data pipelines. Again, no shade to the people on the right here. There are many observability tools out there. They're great. But the default is everyone just takes their raw log data and pushes it into that endpoint and then calls it a day. This is such an enormous waste of money you cannot imagine. Go and look at any S1 out there. From a large SaaS provider, and you will discover tens of millions of dollars of bills. The bills are so big that they have to list them in their S1s. Like, that's how bad it is. And when you look at what they are charging for storage and compute, for generic storage and compute, again, I'm not saying once you get into an index, once you make it traceable, once you add all those features on top, that is great. But those first things, just those initial passes, can be enormously costly. And the reason is because of this. They move all their logs into this thing, they drop them in an S3 bucket. That is not even an exaggeration. That is the most common thing I hear over and over again. Hey, we'll throw it there. Then they have their high throughput compute do the processing on that S3 bucket. And that right there is enormously expensive. Talking about an order of magnitude more expensive than just using a generic VM to do that data processing. And then it lands in the final data warehouse. This is extremely costly, as I brought up many times, but it's also extremely risky. You may have heard of Log4j, this bug that happened a few years ago. That was entirely because people were moving raw, unsanitized logs into their log processing pipeline. They did no analysis on it. I don't want to beat up on anyone. I've done it many times myself. But the reason is because they moved in that opened up their log processing pipeline as attack vector. Right? They didn't even do a first analysis on it. Like, hey, is someone trying to do violate this? Then you get into, like I said, you get into costs, you get into expense, and that key thing at the end. I can't take action on any of these things. If that server in the middle there is flapping, I want to take that out of line immediately. In this architecture, I can't do it until that information gets all the way to the right-hand side. So the idea is be more thoughtful where you're collecting the data. You put an agent like ours. Our agent is very small. It's about 150 megabytes. It takes very little memory and footprint. And then on it, you run any container you want or any binary you'd like. And then you only move a small amount of data, right? Maybe you window, maybe you do other aggregation, things like that. You still drop it in your S3 bucket. You still go through your high throughput compute, and you still land in your data warehouse. But you're doing it with much less. And that speeds everything, it improves costs, and so on. And by the way, what I said before about hey, you know what? I don't just want to move it there. I also want to move the raw stuff off to archival. You can do that too. And the archival stuff is going to be orders of magnitude cheaper. Now it's slower. You're not using it as a permanent storage. Or you were using it as a permanent storage, excuse me, not a warm or hot storage. But that's okay, because it's serving a different purpose. Instead of saying, hey, you know what, everything lands at S3 and then we go out from there, this is a way to make it more efficient. And then the final thing is around securing your customer data before I get to the demo. So a lot of people don't realize how tough the regulations are. A lot of people, again, I'm not a lawyer, you'll want to go contact your own, but a lot of people will say moving even an unobfuscated IP address is a violation of GDPR and other regulations because it is the time and then the IP address is personally identified. I know without question what machine had this. And if I can identify what machine it is, then I can identify the person. Or who had access to that machine, I can narrow down the people to a very small number. So, a lot of people are like, well, I have separate tables. Nope, not compliant. Maybe I have separate databases, also probably not compliant. Even if you have separate pipelines, it's often not compliant. Because of that first arrow here, right? The moment you have the thing leave the server that it's on, you are opening yourself up to risk. I like to joke, there's a playbook, but we're almost compliant and almost is everything under the water, right? What the better way is to have a compute over data architecture, where you are doing the processing either on the machines or nearby machines in the same regulatory boundary, right? So, if you're like, hey, you know what, City of Las Vegas says nobody can leave Las Vegas with personally identifiable information, great, go get a data center in Las Vegas. And then you move all the stuff there. And that's actually something we're doing with the City of Las Vegas. So, you sanitize, anonymize at the point of data collection, and then only the SOC compliant stuff is stored in the global locations. The original pipeline remains in place, and you can still do all those other things I was talking about earlier, aggregation and averaging and windowing and things like that. And by the way, we give you audit logging for free. This is something we do. So every single change, every transformation, everything that this data went through, we give you metadata associated. For those that are curious, you're like, oh wait, we love Kubernetes. Are you asking us to adopt another platform? No, we promise. Here you go. This is Kubernetes on the left-hand side. All you do is you drop your spec for your job into a Kubernetes job, and we execute. So very, very straightforward. We're just a network. We love Docker, we love sed, we love jars, so do we. We've shown WASM here, but the executor's neutral. It really can offer all those things. And we don't like to say it's infinitely pluggable. Ultimately, I'm an engineer, but we haven't found a blocker yet. Let me just put it. And then you say, well, we're entirely on-prem. I don't want your cloud malarkey reaching into my data center. And I'm like, great, so are we. We are entirely on-prem. We offer a cloud for folks that want to get started early and start messing around, but I promise you, everything you see here is installable and set upable in seconds. Really, and that's not an exaggeration. And then I will say one thing that is particularly relevant for data science people. I lied about the demo, it's coming in just a second, but I want to touch on this for data science perspective. This is a really, really common scenario in academic situations. You have two data scientists who want to collaborate, and they're ready to go. And one of them says, okay, well, can I get access to your data? And the other one says, well, sorry, right? And that's justifiable. There's information in there. This is the actual text from GDPR. So not so good. With a platform like ours, or any compute over data architecture, I know I'm supposed to be rah-rahing my product and my company, and I promise you, if anyone wants to talk about ways to implement it, I'm more than happy to. But I also really want to advocate for the architecture as a whole, thinking about how you move compute to where the data is. Here, in this case, you set up your Bacalhau cluster inside your organization. And then our data scientist says, well, I'd like to get access to your data. And she says, sure, submit your job. The job gets submitted. This is the beauty of compute over data. I describe my job, it's got a container, it's got a whatever, it goes into an enclave, and then the person inside this organization can look at it and say, hey, is it exfiltrating anything? Is it trying to delete something? Is it bad? Maybe it's just obfuscated and I just don't like it. Like resubmit with the code. I have no idea. And again, you can verify this with the hash. Once she says it looks good, that's great. It gets submitted. This could be a fully compact binary and things. Runs over the data in place against those local machines. Produces a result. And then that result goes in an enclave. And then again, this person or an automated system, if you've approved it, can look at it and say, let's audit these results. All good. And then she's able to download it. And what you see here is you didn't have to give our person, our data scientist in organization B, the ability to go and log into machines, give her shell access, have her, auto trace, anything like that. It's just ready to go. And we have a feature in our platform called OctoStore, which means that every single one of those events that happen there is traced as well. And again, when I say audit logging for free, this is what I mean, right? So all we do is we track the things that happened, and then we give it to you in a structured format. And every one of those gets a hash. I forgot. I thought I had a slide here that's a demo, but I don't. So I'm just going to go to the demo. Okay. So what does this look like? So what you see here is this is a real live deployment, about 300 nodes spread across 3 different regions of the world. This one is US. And each one of these machines is running a very small model using WASM. And the WASM is just doing something stupid. It's just basically taking an output and producing an emoji. Okay? Very, very dumb, but like you get the idea. Okay? So when I talk about deployment and I talk about rolling things out and figuring out how to get things out there, what do I mean? I mean exactly how do you get that job out to those locations? And for us, it means having a very, very, very simple, straightforward, descriptive way to name, to describe your intent for this particular application. So in this particular case, I said earlier, it's a WASM binary. Again, we support Docker, we support WASM, you name it. You can name, in this case, the person who set up this cluster, me, said, I want you to look for key values that match this. Type, and the type of deployment is edge. And again, that's my naming. You can name it whatever you want. And then region equals US. And in this, I'm going to deploy this binary reliably and give it some environment variables. That's it. Make sense? So really straightforward. That's the end of the file, right? This is how you deploy to a global situation, a global network that we have set up. So again, just to show you nothing up my sleeve, if I go here and I do Bacalhau node list, you can see 300 machines. Show you here. Is this big enough? Okay. Oh, more than 300. 600. All right. Well, I lied. 600 machines. Oh, I know why. Because it's sorry. It's getting each line is 2 lines. Okay. 302 machines. Right? Very straightforward. So now let's say I want to deploy to EU, right? I'm just going to do that exact same thing, except now I'm going to deploy to EU. Now it takes just a second, so I'm going to start it here, and then I'm going to go into explaining what I'm doing. I'm not ready. Just give me 2 seconds. And all this is open source code. You can go check it out on our website. But I'm going to do... and then off I go. So here, what I have done is I've told it to start a job of deploying. And though this is all CLI, we have web pages and things like that, it's just easier to explain a lot of these things when you show everything. But you can see here that I requested this execution across all 100 of the machines that are in the EU. So that's it, right? And when I go back over here, it's probably already, yes, it already went live. Okay? So even before I did it. So let's do it a little bit faster. We'll do the APAC deployment, and I will switch over so that you can see it happen live. Sorry, all this spacing. There it is. Okay, let's go faster. All right, so it's now gone off and told it to deploy, and you're going to see a third region come up here with all the jobs as that node deploys to those regions. And like I said, it takes 10 seconds or so. But what it did was it talked to the network. The network went and found and said, hey, what machines are a fit here for this particular job? If you identify yourself as a fit for this job, come talk to me because I got a job for you. And then they do an exchange and the job gets deployed. Again, this is how easy it is to roll out ML models. So we'll go a little bit further here. What happens when I want to update one of those things? Remember I said updating is one of those things that everyone forgets about? I'm just going to go a little bit smaller here. I hope it's okay. Because my line breaks are just going to here. So what happens when I want to deploy a new version to those things? Here you can see I have a new version here. This one is US version 2. And instead of that blue color that we had there, we're now swapping over to purple. Again, I know it's silly, but like this is just visual for your benefit. And when I go over here, you can see it's already started to deploy and place this. Okay? So 100 machines, different world. And then we start to get into really complicated stuff where it's like, oh no, some, some farmer in Brittany has backhoed through a fiber line. I've just taken all of EU off. What are we going to do? Well, the nodes are still working just fine, but I have lost connectivity to that for whatever reason. So if I deploy, in a lot of situations, this would break. But that's not us. We are built for distributed networking. We're built for eventual consistency. If I go here and I describe the job, you can see it's requested execution, but it hasn't been deployed yet because it's still waiting. It's pending on that deployment because it doesn't have connectivity. And then magically, when I go back here and I unpause, machines come back up, connectivity restored. We will see. Sorry. We will see momentarily that those nodes are swapping out as well. Okay? So again, very, very simple, but again, this is the kind of thing where it will drive your SREs nuts. Why didn't this thing deploy? How do I know it wasn't a network issue? So on and so forth. You're taking this portion out of it. We handle the hard bits of distributed computing. We handle the eventual consistency, all that good stuff. Does all make sense? Any questions here? Yeah, go ahead.
Back to your presentation, it was kind of hard for me to follow between org A and org B.
Okay.
Where like the handing off, I know org B sent off the job to org A, but eventually it still needed the human to overlook the query or whatever job was supposed to be run.
Yeah.
Can you talk more about like how this makes either that easier or how that's this streamlined that process a little bit better?
Yeah, for sure. So one of the biggest, so the question was, how does this architecture help make this easier for our data scientists, for our organization, so on and so forth? Today, the traditional path is to just give people access, right? And again, it's not bad, it's just because that's the only way to do it. So what does that mean? You have to authenticate who this human being is, ideally, with some sort of verification. You have to ensure that they, what rights they have to have at a very granular level. You have to confirm what binaries they have access to, what data sets they have access to, so on and so forth, at the point of granting. Because otherwise, and again, it's not bad, but you're going to be constantly going back and forth and figuring this out and so on and so forth. By doing it this way, you're doing it on a job basis. Now, everyone doesn't necessarily have access to to even these nodes, right? You can do some initial authentication. We support SSO and user password, API keys, so on and so forth. But what you really don't have access to as an external person is the data, right? There's no there's no visibility unless you say about what data is available. So I can do something as simple as just submit a container to this organization over here and say, go run this thing. And I didn't have access to any of their internal tooling, structure, anything like that. But still, over that internal data, I was able to operate and run and do this permission. And our SRE in Org A didn't have to do a lot of thinking about this because they knew that everything that came in would be run under a certain security context, and everything that was output would be evaluated by her before it left. Now again, can you set up other systems that do this yourself? Absolutely. Absolutely. Is it hard to do? Yes. And so what we're doing is we're trying to make it much easier.
Thank you.
Does that make sense? Let's see what else. I guess that's it for the demo. Unless anyone has questions. You want to make whatever APAC some color that somebody wants. I'll do that live. I don't know. I can't do multicolor, unfortunately. Other than that, the project is open source, and we would love people to come and collaborate. Yeah, go ahead.
Since it's open source, do you guys have like a curated first good problems for people looking to contribute, or?
Absolutely. So in our open source repo, we have tags for first issues. You can go check that out. We have a Slack with 1,000 people in it. Always happy to respond and do those kind of things. My recommendation is our docs are open source too, so you can go play around with that. And our examples are open source as well. So if you go here, one of my biggest recommendations is just start on one of these use cases. Try it out. If it takes more than 5 minutes for you to run yourself, come talk to us because that's broken and that's a great thing for you to get started with. As someone who worked in the Kubernetes world for a long time, I will say, here's our example repo. We're better than Kubernetes was, but we're not where I want us to be. And that is I really do want everyone to be able to come and explore and mess around as much as they'd like. Yeah?
So where does Bacalhau, I'm sorry if I'm...
That's okay.
Where does that start, end, and where does Expanso begin? And does Expanso ever plan on doing bare metal as a service?
Very interesting question. So we are entirely open source code. The binaries that we build are commercial. So that means even the one you download from our GitHub or our website or whatever, that's under a commercial license. Now, you can download the code, you can compile it yourself, we don't hide anything, we don't have any special modules, nothing. It's yours. Go enjoy. You can't use our trademark, and you can't use our pre-built binaries. But other than that, enjoy. Same as Red Hat. Okay? From a commercial standpoint, most companies who want to engage with this are fine, I'll pay. And we're happy to collect that money. We do have a cloud, I mentioned previously, we do have a cloud offering, but this really is, this is free. We don't offer any compute here. This is my cloud. This is really live cloud here. These are all my networks that I have set up. These are my benchmarking clusters, so on. Lots of these have half broken nodes and stuff because I'm constantly messing around. But you can see here, these are all the nodes, this is all the jobs I was running on it, so on and so forth. So we have it all, in a friendly website here. But like I said, this is free, right? We do not charge for this. We charge when you use nodes. That's what we charge for on a monthly basis, and that's basically it. Make sense? And you get 5 free. So we have a generous free tier. Yeah.
Are you using AI to look at case logs or your IoT devices?
Are we using AI to
Look at your case logs or spot trends in your devices?
So we don't care what you execute on those devices, right? So we have a bunch of examples that do sensor analysis and things like that, and you can do anomaly detection, and you can do video analysis, and all. Oh, sorry, the question was, are we using AI to look at case logs and device logs and things like that. I will be the first to admit, we are very, very expert, not me, but my team is very, very expert at distributed computing. We are very not expert at sensors or IoT or edge or anything like that. I would say we're not experts at logging, except our CTO is the former head of AWS internal logging system, so he actually is an expert at logging. But generally, what we try and do is not be experts in your business. We try, or anyone's business. We try and be experts in enabling you to take the code that you're running and run them somewhere else. And you can see this in our examples. Like our goal is, brand new model releases on whatever Hugging Face. You throw it in a container, you roll it out through our system, press go, it just works. Yeah, so like I said, the examples repo is a great place to start. So if you'd like to start messing around there, and again, please jump into Slack. Like I said, if you're having more than a minute in getting started, then please contact me. Yeah.
So these majority of the people here are students. They're graduating soon.
Okay.
I'm curious to know what you see as even though they only have a couple of weeks left, I suppose, but what would be the most important skills that you see them needing now and in the future as they continue to develop here academically, but then also...
Yeah, I mean, I very strongly believe in the value of understanding the fundamental. The question was, what are the most valuable things that you should learn as you're a student and leaving, going off in the real world? The space is moving so fast at the frontier level. A year ago you might have said, "Oh, go be a prompt engineer, right? Don't even bother." But like, honest to God, the real novelty here is going to be understanding lots of the architecture. Not that you are going to implement these things, because I'm probably in the minority here, but I think there are going to be like 5 foundation models. That's my personal opinion. It just doesn't feel like a place where there's going to be enough incremental value to justify the cost. Like, if I can go grab Llama or Mistral or whatever open source thing, even now it's state of the art. But like, fine, let's say Anthropic or Gemini or ChatGPT or OpenAI or whatever comes out with something absolutely groundbreaking, it's going to be 6 months before someone closes it. There's just no way to stop it. That train has left the station. But understanding the tools, the mechanisms, what layers they've chosen, what RLHF they've chosen, all these various architectures, patterns, that understanding is incredibly important. But then additionally, like, depending on what you want to do, if you want to go into academia, then of course, there's again, that's far beyond my expertise. You're going to want to go and be smart in your discipline. If you're going into commercial, then all the things I talked about here, and I know my hammer, everything looks like a nail, but like, all the things I talked about here are the things holding people back, right? Like, it's not the model the best of breed model that's going to make the difference. Like, you can do far more by taking an off-the-shelf, year-old model from Hugging Face that has like ridiculous amounts of examples and other things out there, and figuring out how to apply it to the business you're in. That's going to be the biggest difference. And so being able to say, okay, I know how to craft the inbound data, I know how to monitor it, I know how to update it, I know how to test when things start to drift, I know, like, all those techniques, in my opinion, those are the things that are holding people back far more than, like, debating what Ray Lee teaches. Make sense?
Yeah. Thank you so much.